Hello, working hands-on. I'm Samai Haji, and here we have Daniel, Mighty, Misael, Elvis, and Jake. And our project is end-to-end behavior cloning of a prosthetic hand from EMG signals to trajectories. So our objectives were to create a low-cost prosthetic hand controlled by electromyography or EMG signals, processed with end-to-end imitation learning using the Jetson TX2 board. We plan to utilize machine learning to control this prosthetic hand with raw EMG signals using the Jetson as our main controller. In the future, we plan to collect EMG data from 50 human subjects. So over here, we see our diagram of design, where we first have our battery or power supply that powers all of our boards with a constant DC voltage. Then we have our EMG board, which takes EMG signals from a human subject that we were talking about before, and it converts the analog signal to digital to the GPU. The GPU will then the GPU will output the desired actions for the hand, and will be fed into the driver board, and the driver board will convert the digital signal back into analog to the TCP sensors, which will be sent to the feedback board. And the feedback board will also, like the EMG, convert the analog signal to digital to the GPU, therefore creating a feedback loop. We also have our AVR board, which is connected to each channel of a driver, where each channel is a finger, and which will provide a step-down voltage to power the driver. Over here we have our data flow diagram that describes, the data flow diagram is just a descriptive version of how the EMG board works with the neural networks, with R of n representing the desired finger position and Y of n representing the measured finger position. Over here we have our preliminary resolution experimental testing, where we tested the bits for our 4 boards. We have the AVR board being 7 bits, EMG board being 7 bits, flex board being 12 bits, and the driver being 5 bits. Lastly, we have our finger setup in that image over there. And now I will pass it on to Daniel to talk about the controller equations.
So we have 3 different controller equations that we will be implementing into our Jetson. Each equation will be helping control the actual hand. The first one is just a simple proportional control equation, where it takes the difference of the desired finger position R of n and subtracts the measured finger position Y of n and multiplies it by a constant gain or proportional gain Kp. The second one is a feedback controller, where it just takes the feedback control gain and actually adds it into the proportional gain. There is a small mistake up there. And then also takes into account the difference of R of n and Y of n, where the last equation is a special equation that was given to us by our technical manager, where it takes in future and past values of the desired finger position and measured finger position. And then the neural networks described at the bottom, we will be using imitation learning to get the desired and best value of R of n. We'll be using convolutional neural networks, recurrent neural networks, and dense neural networks to achieve A, which is a 1x5 vector, where each element inside that vector is a number from 0 to 1 that represents the desired finger position. And that will be the actual output of our Jetson TX2. Thank you. Any questions?
I was a little uncertain on your data gathering. Are you going to use a real hand
Yes.
with sensors on it so you can get the motion?
That's our goal.
Yeah, so basically the data collection will consist of, right now we're planning on collecting data from 50 willing participants, connecting 8 dry sensors onto a person's skin, 8 equally spaced, that's what we're planning right now, sensors around a person's arm to collect those electromyography signals from people flexing their hands and making certain gestures, and then collecting that data and using it as data to train our neural network to recognize, just what a person is doing in real time.
I'm sorry, so this is going to have both. You guys are going to be creating the prosthetic hand as well as the control system? Is that part of this deal?
So the prosthetic hand, we're working with I think the robotics team of our the UTD team. I think we're actually going to be getting the hand. They already have the way to set up the hand and everything, so we're going to get the fingers and everything. But we're going to be making the controller part of it and the machine learning part.
So they don't have a corporate sponsor. Their sponsor is a lab at UTD led by Dr. Tadessi that focuses on robotic science.
It's not another team. It's a lab.
Lab.
Okay.
Graduate lab.
Oh, I got it.
So you guys, okay, so my premise is understanding is you guys are making it cost effective, so everyone can get this.
Exactly.
So what are you doing that's gonna make it a cost effective product?
So right now, most of the products available on the market, such as like advanced prosthetics that function off of reading electromyography signals from a person's arm, depending on if they need just a hand or a whole, the whole arm. Right now, we're basically, going to be actuating a hand. Most of the market available solutions are anywhere between $10,000 to $100,000, based off of. I would suppose most of the cost comes from proprietary technology and how the prosthetic hand actually processes, these electromyographic signals from a person's arm. Our cost-effective solution, just right now, we're using the Jetson TX2, which is not necessarily top-of-the-line processor from NVIDIA. I think it's what is it? $500 or something. And then our printed circuit boards right now. This is just a prototype. As we move on further, we can make the size smaller and use smaller GPUs, since the TX2 we're using is 2017 technology, as opposed to now, our graphics processors are getting smaller and smaller. So.
All right, let's thank the team.